Hi everyone. I'm going to go through the next trigonometry lesson, which is basically using sine law and applying it to solve for various parts of a triangle. So this is all about sine law applications. So just as a review, the law of sines, or sine law, is a powerful triangle tool which is used to find the missing sides or angles of any triangle. And I just want to emphasize that with SOHCAHTOA, like sine, cos, and tan, and Pythagorean theorem, with those ones you can only use them in right angle triangles, where sine law you can use in any triangle. So it's very powerful. So basically you're matching up angles with their opposite sides. And so this is what it looks like. It's A over sine A is equal to B over sine B is equal to C over sine C. And interestingly, you can flip them all. And it works the same way. So you don't have to have the signs on the bottom. You can have them all on the top or all on the bottom. But you can't have one on the top and one on the bottom, alternating. So you couldn't do something like this. A over sine A is equal to sine B over B. You can't do that. You have to have them either all on the top or all on the bottom. Now, the key thing to using sine law, and I just want to emphasize this, is that you must have, I'm going to put it in capital letters here, that you must have a side and its opposite angle. A side and its opposite angle. If you don't have that, you cannot use sine law. So you're going to see that I'm going to give you an example in tomorrow's, or the next lesson that we do is on cosine law, and you don't need this. And so sine law is typically easier to use, so that's why we prefer to use it, but you must have a side and its opposite angle. And you're going to see today that in all the cases we do have that. All right, well, let's try a few questions here, and these are good examples that they'll be very similar to your homework questions. So here's one that says, find side B of this triangle. So clearly there's no right angle in this triangle. And, there's the symbol, that little square symbol isn't in one of the corners. And even when I look at it, none of the angles look like a right angle. So we can't use SOHCAHTOA, and we can't use Pythagorean theorem, but we can use sine law. And so we'll quickly look, and sure enough, look at this. We have an angle and its opposite side. We have 27.2 centimeters, which is side AB, and we have the side, the angle C there. So let's label this. We'll label this little c. Technically, I could label this little a, but I know that I'm not going to need it. Okay, so let's start by writing our sine law out. So here we go. I'm going to just write the general form. So A over sine A is equal to B over sine B is equal to C over sine C. So that's the general form of sine law. And now let's plug our values in. Well, I don't know what A is, but I'll just keep it as A then. A over sine A is equal to B, that's what we're trying to solve for, over sine of 72 degrees, okay? And that's equal to 27.2 over sine of 43. So there we go. So now what we have to do is we talked about this in the first lesson with sine law, is we don't use all three of them. We only use two. And you have to pick the one where you've got both. So I definitely have to pick 27.2 and sine of 43. And clearly, I am going to work with this combination because I only have one unknown, and that's side B. Okay, so here we go. I'm going to work with this. I'm kind of eliminating this from my analysis. Okay, so I'm going to rewrite it on its own. So B over sine of 72 is equal to 27.2 over sine of 43. Okay, so I want to get B. Well, first of all, I'm going to evaluate these sine 72 and sine 43. So I'm just going to, I'd like to replace them by a number. So I'm going to go to my calculator, make sure I'm in degree mode, and I'm going to hit sine of 72, and it equals 0.951. Okay, so I'm going to go back, 0.951. So B over 0.951 is equal to 27.2 over, and I'm going to hit sine of 43. Now I'm doing it on my calculator now, so I don't have to jump back and forth. And I get 0.682. Okay, we're almost there. I want to get B by itself, so I want to get rid of this 0.951. B is being divided by 0.951, so the opposite is to multiply. I'm going to multiply by 0.951, but whatever I do to one side, I've got to do to the other side, so I got to multiply this side by 0.951. That will turn into 1, and so B is equal to 27.2 times 0.951 divided by 0.682. Okay, here we go. Let's type it in. 27.2, I'm doing it on my calculator. Hopefully you can follow along with me, times 0.951 divided by 0.682 equals. And I get an answer of 37.9. And so 37.9 centimeters is my final answer. Okay, so that's an application of sine law. Let's do another question. Here, this one's asking us to solve for the angle theta. And so here we go. I double check. Sure enough, I've got an opposite. I've got 44 and I've got 29.5. Perfect. I can use sine law. So let's write out, or first of all, let's label. This is going to be little c. This one's going to be little b. Okay, so here we go. A over sine A is equal to B over sine B is equal to little c over sine of c. Okay, so there's little a down there. I don't know little a, so again, I'll just label it. It turned out to be the same two that so I don't need really either of those, but I'll just keep them for now. B is 29.5 divided by sine of, its opposite is 44. So notice that those two are opposite one another. It's equal to 37.1 divided by sine of theta. So there it is. We could call it sine C as well, but there it is. And so sure enough, I only work with two. I'm going to work with those ones. And the reason why I'm going to work with those is that there's only one unknown, and that's the theta, sine theta. Okay, so I'll pull those down here. 29.5 over sine of 44 is equal to 37.1 divided by sine theta. So we want to get sine theta on its own, and we want to get it on the top. Right now it's on the bottom. So look at this. I'm going to multiply the top on this side by sine theta, and I'm going to multiply the top on this side by sine theta. That will leave me with sine theta over sine theta, which then turns into 1. Anything over itself is 1. So the nice thing is that got it on the top over here. Now, you may say, well, boy, you put more stuff on that side, and that's fine because I can get rid of this 29.5 now. So watch this. Right now it's being multiplied by the sine theta, so I'm going to divide this side by 29.5. But I've got to divide this side by 29.5. Whatever I do to one side, I got to do to the other. And I'm going to multiply by the sine of 44. So look at this. I'm multiplying this side by sine of 44. And I have to multiply this side by sine of 44. Maybe I should have got rid of and turned that into a decimal. But anyway, it doesn't really matter. I'll get rid of it there. So I've got a sine 44 over sine 44 is 1. 29.5 over 29.5 is 1. And then here we go. Sine theta is equal to 37.1 times sine of 44 divided by 29.5. So I'm just rearranging, and here we go. So we're going to type those into our calculator. I'm going to do it on my calculator. Sine of 44, so sine 44, and that's 0.6946, and so on, times 37.1 is 25.77 divided by 29.5 equals, and I got 0.874. Okay, so sine theta equals that. Well, to get the angle, whenever you get to one of these points where you've got the sine theta equal to, in order to get the actual angle, you've got to do this inverse function, sine -1 of 0.874. So let me show you how to do that on your calculator. So here we go. I'll clear, and I go inverse sine, or sometimes you say second sine, and then you put in 0.874 equals, and there it is, 60.9, or maybe if we went to the nearest degree, 61 degrees. So equals 61 degrees. Okay, so we can use sine law to solve for an angle as well. Okay, let's try a couple of application questions here. So this one says, find the distance from tower B to the fire. So these are two forest fire towers, and they're separated by 10 miles, and the forest fire is burning up here at this one corner of the triangle. So we're being asked to solve for, and we call this a tower A, so I'll call this capital A, I'll call this capital B for tower B, and I'll call the fire capital C. That makes this side little a, that makes this side little b, and this side little c. So we know that little c is equal to 10 miles. Now we want to solve for little a. Now some of you may look at this triangle and say, well, wait, you can't use sine law because you don't have an angle and its opposite side. Because I don't have angle C, which would be opposite 10, and I don't have either A or B, which would be opposite 42 and 64. Except here's the key, is you do actually know angle C, because you know the sum of the angles in a triangle is 180. So you know that angle C is 180 minus 42 minus 64. So here we go, 180 minus 42 minus 64, and you get 74 degrees. So sometimes you do have everything you need. You may have to just do a little something to get it. So there we go. We've got a set of opposites. Okay, so let's write out sine law. A over sine A is equal to B over sine B is equal to C over sine C. Okay, let's plug our numbers in. A over sine of 42 is equal to B over sine of 64 is equal to 10 over sine of 74. Okay, so there they are. Now, we're interested in the distance from tower B to the fire, which is little a. So look at this. I really want to use this one and this one. The reason why I want to use this one is because it's got my little a in it, which is my unknown. And the reason why I want to use 10 over sine 74 is that I know both parts of that ratio. So I'm going to put those together and use those to solve this. So here we go. A over sine of 42 is equal to 10 over sine of 74. Now let's get rid of those sine of 42 again. I think a lot of times it's nicer just to work with the decimal. So sine 42. So we've got A over 0.669. I just typed sine 42 into my calculator. And 10 over sine of 74 is 0.961. Okay, we want to get a by itself, so we'll multiply this side by 0.669. But whatever we do to one side, we've got to do to the other, 0.669. And that turns into 1, and so we've got a by itself. And so here we go, 10 times 0.669 divided by 0.961 equals 6.96 is little a. So, and what they were using miles there, so 6.96 miles is my answer. Okay, let's try another example here. Oh, this is a good one because this one is a two-step problem. So it says find the height of the tree below. So basically we look at this, and what I want is this side of the triangle. Okay. Well, I've been given something over here, this 20 feet, and I've been given the 45 and the 75, and I want to get over to here. Now, one thing I know is that this is a right angle, so that might be useful at some point. That's a right angle in that corner. But at this point, I only have an angle in that triangle over there. I'm saying in this triangle right here, this one, I only have a 75. And even if I looked at the big triangle, even if I looked at this big triangle, I only have the 45 because I don't have, this 20 feet isn't the whole bottom. But what I want you to see is that maybe what I can use is I could use this little triangle in here. Now watch this. I'm just going to actually erase this to allow me to show you guys a little bit easier. Okay, so here we go. Look at this. Because this is a straight line, we know that that is, I can say that that must be 180. So I know that this angle in here must be 105 degrees, because I know that for a straight line it's 180, so that angle is 105. Once I know that, I also then can get this angle here, because I know the sum of the angles in a triangle is 180. So 180 minus 45 minus 105. So 180 minus 45 minus 105, and I get 30. Okay, so look at this. I know that this is 30 degrees. So I'm going to pull that triangle out of there just for a minute. I'm just going to do my best here. I'm sorry that if it's not perfect. So we know that this is 45. This is 105. This side length is 20. And this is 30. So I'm going to label that triangle now. I'm going to call this, I'll just call this capital A, capital B, and capital C. This is little a, this is little b, and this is little c. Oops, I don't want to do that. This is little c. So look at this, you guys, is that if I could get little a, if I get that side, all of a sudden I would have two parts of that triangle. And so I think that might be enough to solve this. So here we go. Let's work our way through this. So I'm going to get little a. So I'm going to use sine law. So I'm going to go a over sine a is equal to b over sine b and c over sine c. Okay, so here we go. Little a over sine of 45, those are my opposites. So over sine of 45 is equal to little b, which was 20, over sine 30. And it's equal to little c, which I don't know, over sine of 105. So let's try to get that side of the triangle, which is little a. So I'm going to work with these two parts of my sine law. So here we go. A over sine of 45, so I'm going to get rid of that right now. Sine of 45 is equal to 0.707, so A over 0.707 is equal to 20 over sine of 30, which is 0.5, 0.5. And so I'm going to multiply this by 0.707, multiply this by 0.707. That gets rid of it off that side. And my A is going to be equal to 20 times 0.707 equals divided by 0.5. Okay, so it turns out to be 28.3 meters. I think it's all meters. Feet. Okay, so look at this. By doing that, I have solved for this side of the triangle, and I've got 28.3 feet. 28.3. But listen to this. As soon as you know one side and one angle in a right-angled triangle, you're done. You can use SOHCAHTOA at that point. So watch this. I have the 75, I have the hypotenuse, and look at this. This is going to be the opposite side, and that's going to give me the height of the tree. So I'm going to redraw that triangle. I'm just going to draw it down here. So I've got a right-angled triangle. I know that this is 75 degrees. I know that this is 28.3 because it shared that with the other triangle. And I want to solve for x. And again, because it's a right-angled triangle, I'm going to use SOHCAHTOA. And so according to the 75, x is opposite, and 28.3 is hypotenuse. And so I'd go, oh, well, look at that. I'm going to use SO. I've got the opposite and hypotenuse, so sine of 75 degrees is equal to opposite, which is x, over hypotenuse, which is 28.3. And then I can get the 28.3 off of this side by multiplying it by that side. But whatever I do to one side, I've got to do to the other, 28.3. And so x is equal to 28.3. And what's sine of 75? I'll type that into my calculator. So it's going to be 28.3 times 0.966, which is just sine of 75. So times 28.3, and you get 27.3 feet. 27.3. So the tree would be, the tree is 27.3 feet high. Okay, so that's a two-step problem where you first had to use sine law to get something in that right-angled triangle. Once we hit the 28.3, we used SOHCAHTOA and got the height of the tree. So that's one of the harder problems that you would have to do. All right, I've put the homework on here, so if you can work through some of these homework questions, that would be fantastic. Take care, you guys.